Okay, in this video, I'm going to show you how to use GeoGebra to plot some surfaces, and we're going to use spherical coordinates for this. So I'm at geogebra.org, and I'm going to click on 3D graphing here, the new math apps. It doesn't really matter, you could actually use classic, it works just the same. So I'm going to click, and it opens a new page, and you can see that that kind of launch page is still over here, but now I'm in this page. And you can rotate this, just click, grab, and rotate. Sometimes you want to turn this plane off. I'm going to right click or two finger click and just click show plane. Or you can turn it back on. I'm not sure what'll look better, so I'm going to leave it on for now. So we want to plot a surface. So a surface in general, if you type surface, you can see it'll explain to you what you need. You need an expression, an expression, an expression. So it's three-dimensional. And then there are going to be two parameters. So the first parameter, its start and end, and then the second parameter with its start and end values. And so there's actually a lot that you can do with this. So surface, I don't know, I'm going to do just t comma v comma 1 comma. So I'm going to let t go from, I don't know, -2 to 2. I'm going to let v go from -3 to 3. And I'll press enter. You can see it's already graphed it. I'm gonna press enter to kind of get a new place where I could enter something. And now if I drag this, you can see it gave me a plane. Let me turn this off now. So, there. So I have a plane. It's up at z equals 1. But what's nice about it is that it's very limited, so it doesn't go everywhere. And that's one of the advantages of writing a surface parametrically instead of, I could have just typed z equals 1. And it'll plot it, but when it plots this, you can see that it's everywhere instead of that limited little piece. So that's one of the advantages of using parametrics and this surface command. All right, so what I really want to do is I want to do some spherical things. So I am going to first plot a sphere. So you would think that that would be super easy. I mean, in spherical, the equation of a sphere is basically rho equals whatever the radius of the sphere is, which is not a big deal. The issue is that GeoGebra doesn't like that, and so we can't really enter that equation. So instead, I'm going to write it parametrically. So surface, and I know that in spherical, x is equal to rho cosine theta sine phi. So I'm going to say that my radius is, it looks like I could get away with 3. So I'm going to say rho is 3, so that's a radius. And then cosine, I could actually use theta. I could get up this keyboard that's down here, and then go into the Greek letters and use these, but that's kind of annoying, and the program doesn't really care. Now it's giving me an error. Let me click back in here. So I'm just going to use t for theta, and then I'm going to use v for phi. So that's what I'm going to do. So that's x. X is rho cosine theta sine phi. And then y is rho, which is 3, and then sine of theta, which I'm using t, and then sine of phi, for which I'm using v. So you want to make sure that your parentheses are working out. Like, make sure you don't do sine of t times sine of v. Like, that extra sign sometimes ends up inside the parentheses. You definitely don't want that. Okay, so I have this, and now I need z. So z in the conversion is z is equal to rho, which is 3, and then cosine of phi, and I'm using v for that. Now I have to decide what to make t and v vary for. So I want to get a full sphere, so I'm going to let t go from, so t is the angle in the xy plane, so I start at the positive x-axis and I rotate counterclockwise. I want to actually go all the way around that plane, so I'm going to say 0 to 2 pi. And you can see I still have this yield sign, which just means I haven't kind of finished everything that is necessary for a surface. And it also is offering to create a slider, but I don't want to do that. I actually haven't clicked that for this particular command. I'm not sure what it would do. Hopefully it would make sliders for t and v, but I'm not sure. So v is phi, and phi is the angle between the positive z-axis and, well, it's just the angle formed with the positive z-axis. So I want that to be able to go from 0 all the way down to the negative z-axis, so 0 down to pi. And as soon as I do that, I'm going to press enter to kind of get it done, and then click here, and you can move it around, and there's your sphere. So that's pretty interesting, and you can see it has these radial lines, like longitude and latitude lines are on it. I've always liked that. And it's kind of see-through. You can see dotted lines that are behind the figure, and it dots the axis through it. So now let's see if we can make this more interesting. So I would like, instead of having my parameter, so you can actually click and drag here, instead of having my parameter for t, so theta, go from 0 to 2 pi, I'm going to create a slider and call it t1, and I'm just going to click create slider. And then I'm going to click here so I can edit this. I'm going to start at 0. I'm going to click here. Tab should work between those, but it doesn't always work for me. I'm going to go to 2 pi, but I think it has a rounding problem that a lot of programs have. So 0 to 2 pi, and then go up here, click so that I can edit, and change this 2 pi into t1. And now you start to really get a sense of how spherical coordinates work. So right now I'm graphing, but my theta value is only going from 0 to 1 instead of 0 to 2 pi. And you can kind of play around with it. If you accidentally do that, it'll just keep rotating. So it's going from 0 to 1. So looking down on the xy plane, if I drag, you can see when I get close to pi over 2, be like 1.5-ish, 1.57. You can see we get like a quarter of it. And if we look, we can see this. So you get a really good sense of what theta is doing when you do this kind of thing. What'd be nice is if I could also get a good sense of what phi is doing, and it turns out I can do the exact same thing. So if I drag this all the way to 2 pi, you can see it doesn't quite get there, and so it doesn't close the sphere. So one of two things you can do. You could just live with that, which is not really a problem, or you could click there, make it, so the key here is I don't know what the step size is. I'm just going to change this to 9, so that's a little bigger than 2 pi. And then let's see if it'll let me go that far. Oh, it still won't let me go that far. What if I make my step size 0.01? And go. There we go. It closes it off. All right, so solve that issue. A lot of programs have that issue. And this is free, so you can't really complain. All right, so what I'm going to do now is I'm going to mess around with phi. So that's v. I'm going to call the slider v sub 1, or v1. You don't want to mess around with subscripts. It's not worth it. v1, click create slider. This one I only need to go from 0 to pi. So let's see if I don't know what round, it's kind of inconsistent with its rounding error, so I'm just going to go from 0 to pi. You can see here it leaves it as pi, and here it had changed it to 6.28. I don't know why it does that. So this right now isn't doing anything because I didn't tell it up here, instead of going to pi, let's go to v1 and press enter. And you can see, sort of, that the angle formed, so we're going from 0, and then the angle formed is coming out here. It's 1.9. Let's make it as close to pi over 2 as we can get. So pi over 2 would give us this. It forms this between the z-axis, and I'm not sure if this is the x or the y right now. I think this is the y-axis. So pi over 2 angle. If we keep going, you can watch as it just fills in the rest of the sphere because that angle is increasing. So once you have these set up, you can learn a lot about how the angles work, and it gives you a really good sense when you have to set up integrals later in life, what bounds you should be using. All right, so that's a sphere, and while I'm here, I think I'm just going to end this video here, and I will come back in another video, and I'm going to mess around with parametric equations for a cone that are written in spherical coordinates. So I hope you found something helpful here. We made some sliders, we graphed something parametrically, you can play around with it, it's a really good idea. Close it off, you can get a hemisphere, you can get, oh, it is doing the rounding thing. Just misses closing it, you can see that. Alright, so we could fix that by making this 3.15, and then make our step size 0.01. I don't know what the default is, but it's not enough. And there. Well, I animated it, so it's going to do this weird thing. Alright, so that's this whole video. I'll be back in another to talk about cones. I hope you found this helpful, and good luck.